The broadcast is now starting. All attendees are in listen-only mode.
So we'll continue from MapReduce, guys. How it is processing any data. Okay, so first we'll understand entire flow of MapReduce. How many different components they're using, and how parallel processing works actual in a cluster. Because so far we have seen storage part, how we are storing data in a distributed format in a single node cluster or multi-node cluster. So don't worry about the which language I'll be using. When we write a program, I'll be mostly preferring a Scala language, because going forward, when we start Spark module, we'll use a Scala. So for any kind of programming, whichever comes here in our course of Hadoop, we'll use a Scala as a programming language. And I'll try to relate that with the Python also. So people who know Python or not so good with the programming, they can relate things with a functional programming language, that how the same thing can be written in Python. Now let's say this is mainly for historical data analysis, right? So let me write it here first. MR is designed to handle historical data and again store in HDFS. Okay, so now what type of data that's important? What is the input format? Is it a structured, semi-structured, unstructured? And if it is a structured, then from where we're extracting the data? If it is semi-structured, is it a CSV, JSON, TSV? So we need to know the format of data first. Okay, because just think, if I give you a task and I ask you in this task, uh, write a MR program, write a MR program to process, and this can be any type of process, right? Transformation, aggregation, to process 10 GB of data. If I give you this task, so without knowing this format of data, you cannot write a single line of code also. So first you need to know what type of input format is this. Then once you know the input format, then you can write a output format also. Now one additional point with MapReduce, they provide you custom input format. Okay, so custom input format, as in we can create our own input format, we can create our own output format, right? Now let's say I have a 10 GB data. I'll take this as an example. Okay, so 10 GB data, if I have, how many blocks will it create? Or to simplify it, since we'll have 4 to 5 machine, so how many blocks will be there? Let me keep 1 GB data. So 1 GB is my total data. I'm not talking about the format of data currently. I'm just talking about the volume of data. Now this data is stored in your HDFS. So here is a client, or let's first calculate how many blocks we will have for 1 GB data. So block is equal to input split. I'll tell you what is input split. Block is exactly equal to number of input split. Okay, block is a physical division. We refer this block as a physical division, and input split is a logical division. So whenever you submit any MapReduce job, okay, whenever you submit any MR job in your Hadoop cluster, this is the flow which starts. So we have total 10 different steps in MR. First, input. This is stored in HDFS, because first requirement of MapReduce that input should be available in HDFS. If you don't have input available in HDFS, you will get exception. Input path does not exist. So these are some known exception in MR. If input is not available, it will throw you that input is not available in the path. After input is split. I'll explain you one by one all these individual steps. Okay, let me write down the flow first. Input is split, then record reader, mapper, combiner, partitioner, shuffle sort, record writer, reducer, and last is my final output. So this input and this output, this both are stored in HDFS. Now from input split to reducer, this step is happening where? This step is happening in node manager. So from input split to reducer, all this step is happening inside the node manager. And if you remember node manager in a multi-node cluster, data node and node manager are located together, are residing together. And why we are keeping data node and node manager together in single machine? Let me draw a picture here. Data node and node manager. I think we have seen this already, but again we'll revisit this. So if my data node and node manager are in separate machine, so IOPS time will be IOPS time will be high. They will take a time to read the data and process it, right? Simple concept of data transfer. But if I'm keeping in the same machine data node and node manager, then it can uh, the time for process of this data will be very less. Their IOPS time will be less. This is a basic concept. Whenever you communicate from one machine to second machine, the communication time is high. If you're communicating within the system, the communication is low. That is why we keep this data node and node manager together. Though we can keep master in separate machine. That is that is how your master and slave is configured in multi-node cluster. Okay. So this will happen whenever you submit a program. And what is the command to submit a program? So block is equal to input split. You're seeing this input split. This is a logical division. Now suppose I have 1 GB of data to process. How many blocks will it create? If I am using by default block size, I'm not customizing it. So this block size is by default 1 GB divided by 128 MB, right? Which is giving us 8 block roughly. So if block is 8, input split will also be 8, and input split is equal to number of map task, which is also 8. So for now you understand that this 8 block is processing in 8 different core. So if I am saying I want to process this all the data parallelly, I need 8 free core. If number of core is not 8, then my job or my task will go in a queue. My job will go in a queue, and then it will take a time to process it. So if I'm suppose working in single machine, I have just one machine available. This is a single node cluster, and all my services are running here: name node, data node, secondary name node, node manager, resource manager. And here my number of CPU is 4 in single machine. Okay, so 8 a time, how many core you can process? How many tasks you can process in 4 core? 4 tasks in 4 core. So simple understanding here, guys. Number of tasks is equal to number of CPU. This is how it is processing. So if I have 5 machine, then this 4 CPU multiplied by 5, and I will be having total 20 cores. Then I can run 20 tasks parallelly. So let's see the picture. This is my client who copies the data. So this client is mainly master, or it can be a edge node also. In production, we call this as a edge node. So this edge node has already copied data in your Hadoop distributed file system. So this is your HDFS, and client has already copied this data here. This is my 1 GB data present in HDFS, which I can access from any machine. Now I'll create a jar file using my ID process. So how do we create any program in MapReduce? MR program. I believe you all have IntelliJ installed in your system. So let me open the IntelliJ first. This will take a while to start. Now, since you want to create a project, okay, if you guys are doing first time, you have installed this in your system, and you want to install some of the plugin. So you can go to this option called configure. Click in this configure, and the second option, plugins. Click there in plugins. This option Scala coming as at first, and since I have already installed this plugin in my system, that's why it is coming as installed. If you're doing first time, you'll get like this enable option. Okay, you just need to click here, and automatically this will be downloaded. Make sure your system is connected with the internet. This needs the internet. Okay, once this is installed, I'll create a project. So I'll click on this create new project. Can you see in your left option you have multiple programming languages available? They are giving you option for Maven. This Maven is for people who program in Java. Scala. Now we will use here SBT, simple build tool, to create our project in Scala. If I'm writing any line, there's an option for Python. There's an option for Kotlin, Groovy. Many languages are there. Let's not go to other languages. We'll focus on this Scala. Okay. So SBT is what, guys? SBT is a simple build tool. Simple build tool. Look, there are two options. Whenever you write any program, there are two options. One is without built-in tool. Without built-in tool. What do I mean by without built-in tool? So this Maven Scala which you're seeing here, this is all built-in tool for programming languages. If you create your project using SBT, so automatically all the plugin, all the Hadoop related dependency, all the Hadoop related dependency, it will download from web. All the jar file, it will download from web. You don't need to do anything. Okay, if it is SBT, so we can say one is with built-in tool and one without built-in tool. SBT, Maven, this provides you built-in tools. So you just need to use a version of Java and Hadoop. Okay, so let's say you are working with Hadoop 2.9.2, Hadoop 2.9.2. So you need to download the plugin of this, and I just need to go to web and search for this. You'll see here what I'll search. So I'll open a tab. and type Hadoop Maven. You get a first link. Click on this link, and Hadoop Client Aggregator. Second option, which version you're trying to build. So version, you can pick up anything based on your server, which server you're using, and in your server which version of Hadoop you have installed. So in your server, if you have Hadoop 2.6.0, okay, this is one important point to note. As I am keep saying, from first class Hadoop is compatible. Here we have many compatibility issues. If you're not checking version, uh, you're not checking version of server and your local machine, how you're creating your program. Okay, so if you're not taking care of your versions of Hadoop, let's say in my standalone machine, I'm building my project using Hadoop 2.9.2. This is in my standalone machine. Standalone machine. This is my local machine. Okay, and this is my server. It can be a GCP server, AWS server, Cloudera, or any distribution packages. Now suppose Hadoop is 2.9.2 here, and here I'm having Hadoop version of 2.6.0. Then this will give you the compatibility issues. Always remember, your target, your destination should have a higher version. So you are building your code right here in this machine. You're building your code, you're creating a job, or I can, if I say in a binary terms, this is known as a jar file. I'll create a jar file, do not worry. Just wait. You're writing a job and you're converting that job into jar file, and then you're copying this jar file from your standalone machine to server using FTP software, FileZilla and WinSCP. Now the moment you copy, the copy will happen, but version is differ here. Your main standalone system is having 2.9.2 and your actual server is having 2.6.0. Okay, if it is interchanged, right, I have a lower version in this standalone machine and higher version in this server, then definitely it will work. So can we write one note here just to remember? target server Target server should have higher version, always higher version. Just one thing to remember, not just, this is not only applicable for Hadoop. Let's say here in this machine you're using JDK, right? Because to build a job of Hadoop you need a JVM, Java Virtual Memory. Hadoop programming is built and using JVM services. So whatever daemons you're talking about, they uses JVM. This is built in native C and core Java. That's why you need a JVM, right? Or to run any program, if you're a OOPS programmer, you know that JVM is very important. If JVM is not set, your program will not run. So if you're using Java version of 1.7 here, and you have installed JVM of 1.8 here, this is perfectly fine, guys, because here you have lower version and this is a higher version. But if you interchange this, you say, so this is case number one. In case number two, you say I have 1.8 in my standalone machine where I'm building my code and job, but in my actual server where everything is running, this is my dev server, and here I have 1.7. Then again, this will give you the compatibility issues. There is a fixed error which comes as unsupported version error, unsupported version error, and this error code is 52.0. This error will come whenever any compatibility issues you have within Hadoop for Java, for Hadoop version. So if you understand me, this side should have always the lower version, and your target server where you're copying everything should have the higher version. Okay, then it will definitely work. So that's what I'm doing here. If I'm using 2.9.2 in this machine, so this should have 2.9.2 or more than that, not the lower version. So equal version will also work. If I have 2.9.2 available in this machine, it will work, or I should have higher version than this. So when we're building, this is important. Now I'll take this one, 2.9.2. Let's say you guys are a Java programmer. Some of you knows Java and you want to write your code in Java. Okay, so you will use this plugin. You'll copy this and create a Maven project, paste in the Maven side. But since we are doing our things on a Scala, that's why I will click on this SBT option. SBT stand for Simple Built Tool. I'll copy this. I'll copy this. Okay, just for now I'll copy and later I will paste it. Scala. First option is SBT. Then click next. Again, remember, internet must be there in your system, in your local system, when you are creating any SBT or Maven project, because they will download all this plugin or dependency from web, and that web is a mavenrepository.com, provided again by Apache. This is again one of the Apache project. Version you can see my JDK is 1.8. Now Scala 2.12 is not stable, so I will use lower version, one version lower, 2.11. SBT I will keep it same. I'll not change this. Any other option? Project name. So project name I can give as HD weekend 11:45. I'll just give a logical name so that when I open my IntelliJ next time, I remember that this project is created for this batch. So this name can be anything, okay? Just a logical name. Finish. And where this project will store in my local machine, this is the directory location. This stands for home user, home and username. I'll show you. Let me create it first. Then where this is stored in my local machine, we'll see it. Close the box. This will take a minute, guys, because it will first download all the Scala related plugins. Okay, so you can see here in my cursor. Uh, once this uh, processing is done, you will see here a checkbox. So once checkbox is there, which means your project is readily available. So we'll just wait for a minute. Okay, so project syncing is done. It took us 2 minutes of time. Okay. All right. So Scala version and SBT version. So Arfa, Scala version means which version of Scala I'm using to write my code. Okay. And SBT version. So if you understand this two part, if you understand What I'm saying, two things, right? One is without built-in tool. This is one option I have. Second, I'm using built-in tool. So this built-in tool is, in our case, since we're writing our code in a Scala, so this will be SBT. SBT stands for Simple Build Tool. So Simple Build Tool is coming with a separate version. Like whenever you add any APIs, when you increase your plugin version, so SBT version is there. But this SBT version is using the Scala version 2.11, 2.10, 2.12 to sync up and download all the Hadoop related, Spark related, Hive related dependency, whichever code you are writing. Suppose you're writing for MapReduce, it will download all the APIs, all the application programming interface related to MR. Suppose you're writing code in Spark. Okay, let's just say you're writing code in Spark using again SBT, Scala. So it will download all the API, application programming interface related to Spark. So which version of Spark you are giving and which version of SBT you are giving the sync up with the version. Okay. So in Spark, if you know current Spark version is, because MapReduce is nobody is writing any code in this MR today. So the stability or the version APIs progress they have stopped it. But Spark current version is 2.4.5. This is a stable version. Though their testing is going on in 3.0.0, this is an alpha version, but current stable version is this. Now, if I want to download Spark related API using SBT, so I will have to give this version 2.4.5. I'll come to the practical. Okay, let's not focus on the theoretical part. Let me do it actually in front of you, right in IntelliJ, then you'll understand what is the use of Scala version and what is the use of SBT version. Now, what do I mean by without built-in tool, guys? So this is what I'm doing currently. Without built-in tool means all these things are manual. Manual means, let's say I need 100 different APIs to write a MR program. Okay, 100 is even very less because sometimes we need 10,000 of different dependency and different jar file. So if it is a manual, you know what I need to do? I need to manually add all the jar file. If you miss any one jar file also, if you miss any one dependency also, your code will not run. So this is not a right and good practice. We in production we never use such method. We don't do manual because in production we are not having dependency of one module. We are having dependency of multiple modules, and sometimes we end up adding 10,000, 20,000 jar file. So if I'm adding 10,000 jar file manually, you can see the risk of error. Or if I miss any jar file, then I will have to face the troubleshooting and errors in my program. Okay, so always remember built-in tool. If you are thinking that I will write in Java for Maven, if you are thinking I will have to build my code using Scala, so SPT, simple build tool. I'm going to do this. Manual approach is not recommended for you. Once this is built in, okay, so I'll click on this. I expand my project, click on SRC, expand main, Scala. Right click here, and there should be one Scala class, but currently I can see only Java class and Python file. There is no Scala class. So it happens when you create first time in IntelliJ. Now, what is the hack or solution for this? When you're not getting a Scala class, you just need to rerun this. So if you refresh this option, it will take 20 second, 30 second again, and refresh your options. This comes whenever you start first project uh, in a Scala. This is a internal issue or bug I can say of IntelliJ. So you need to always refresh this option. Only first time, okay, not always. So let's wait for another few seconds. Again checked. Right click here in Scala. Can you see now just next to Java class, there is a Scala class. So let me open this Scala class. Now you want to write a class, you want to write an object, you want to write a threads. So Scala, I think it's all new for you guys. Okay. So I'm not going to write any a production code here. I'll just write a sample code to tell you first how to create a jar file and submit it using server in Hadoop. Let me say this is testing file or mr underscore test. This is my class name, and I'll access one file here. So I'll say a is equal to 10. Don't worry about the syntax what I'm writing, because the Scala we have not yet started. Object mr if main, and I will instantiate this using new mr test dot a. I just want to access my variable called a and print this. So some of the logic I have written. Now, if you follow this flow, what I did first, steps to create a program. First, open IntelliJ. Second, install Scala plugin. Third, create SBT project. Fourth, create package. If you're writing multiple classes, if you don't want to write a package, it will take a by default package and then directly you can create a class. Then fifth, write business logic. Business logic means how to process the data. Okay. To processing the data, we need to write some logic. And this is my business logic. What I have written currently, this is nothing but I can say my logic, simple logic, to access my file A, variable A. Once this logic is built, sixth, I will compile this. So let me compile it. We'll go step by step. First, I will compile this, and to compile this, you just need to click write and run. When you click run, can you see this is building at building stage? So once this processing is done, it will run and print me here value 10. Compilation finished, there is no error. Now output is coming as 10. So I just have created one variable and accessing from my object. Okay, very simple code. So after compilation, where is my SBT now? So SBT is right here, build.sbt. Double click here. Now suppose I want to add Hadoop dependency, right? So I have copied my Hadoop dependency from here of 2.9.2. Copy this and paste it here. The moment you paste it, if you see my extreme right down, there's an option coming import changes. Okay, so if I click on this import changes, if I click on this option, then all Hadoop related dependency specific to this version dependency will download in this folder, external libraries folder. Okay, this version is again important based on your server. So make sure in your server you have equal version or higher version. If you have in your server, let's say 2.6.0, So you should have 2.6.0 here. If in your Hadoop server you have 2.2.0, you'll have to take 2.2.0 right here in this. Now we want to download this. So import changes. Click on this import changes. Now from where this plugins are getting downloaded? Any idea? These plugins are getting downloaded from this website. And that's why you need internet for this. And we call this is a built-in tool. So once the whole download part is done, my all dependency related to Hadoop will be aided in this external libraries inside this. We'll see once the job is done. I think this will just take a minute. So let me complete this guys first, okay? If any question, if you guys are having, we can see that question then. Okay, so once this is done and finished, it took us 3 minutes cumulative time from CPU to download. Click on this external library and all this jar file, Hadoop related jar file are aided in your project. This is aided in your project now. Suppose this is not there and you start writing some of the MR job. Okay, I've not written any MR code. Let's say you start writing MR code here. So your code will have so many errors because this API is not satisfied. Okay, that is the reason you will have to aid this built-in to understand me now. Since this is compiled and I have tested my code, all the dependencies I have added. Now after that, I will go and create a jar file. So I'm doing seventh step now. And my seventh step is create a bytecode. Create a bytecode. This bytecode is your jar file. Now, what I have written here in this line, this is all my assembly language. This is my assembly language. And from assembly, I want to convert this into binary language. And why I'm doing this? Because my system does not understand the assembly. My system understands 1 and 0. Right? This is the reason I need to create a bytecode. So there is a jar file creation. People who have worked in Eclipse, right? This is very similar as Eclipse, but I have worked in Eclipse as well. But personally, I feel for a Scala programmer, IntelliJ is lightweight. It provides this autocomplete option, and it is way fast than Eclipse. This is a lightweight option. So if you have worked already in Eclipse, some of you understanding what exactly I'm doing. People who have never uh, get any idea about how IntelliJ or how IDE works, we will come again here. I'm just giving you the taste of it, like how we can create a jar file. Once this understanding is clear, I will come there and create actual project and write actual MapReduce code after learning Scala. So before learning MapReduce program and APIs, we need to know one language. It can be Java, Scala, or Python. But as you know, Java is very complex and it takes time to process the code. So that's why I will be using Scala or Python to write my jobs. Today, if you see the trend also, uh, it has moved from Java to Scala, and most of the APIs or tool we are creating using Scala versions. talk about Spark, Kafka, Neo4j, Scalding. This is all built in Scala. I will quickly compare Java versus Scala. Okay, then you will tell me that yes, I also want to use Scala. I don't want to use Java. Now I'll go to File and Project Structure. In project structure, this is my project name. I'll go to artifacts. Now within this artifacts, you'll have to click plus. Jar. Jar stands for Java Archival. So Scala is a wrapper of, it's built top of Java. Okay, it's not writing the syntax of Java, but it is using JVM. That's why it is also building jar file only. Now, what is your project? If you see left side, HD weekend 11:45 a.m. This is my project name. I'll select this. Main class. Select this option, automatically it will search it for you. This is my class. This is my object name. Say OK and OK. Once this is done, okay, then apply and OK. So this is built in my artifact ID. Now I will go to build option. Click on build artifacts, second last option, and by default there is coming for option: build, rebuild, clean, edit. So rebuild means if you have any error while building, right? So you can rebuild it. If you want to clean the project and want to start from scratch, then you can clean it. Edit if you want to change anything here. I want to build it here because all things looks fine to me. Click on build. Now my actual jar creation is in progress. Once this is done, you will see here one folder, out folder. So out folder will be created, and inside that out folder we will have our jar file. Can you see it here? This out. Expand this. Expand the artifact. Your folder name of jar, and this is the jar. Jar comes with the extension of .jar. But where this file is located in my local system, right click, copy path, and I'll go to my terminal. So minimize this. If you're using Windows, it will give you the path of Windows, some C drive or D drive, whatever drives you have in your system. Currently, mine is following Unix operating system, so I have stored this inside this folder. I'll use CD. CD stands for change directory, and I'll go inside this folder. Use lslrt. This is my jar name. What is the size of jar name? Can you see it? This is in bytes. To check this option, I'll say du minus h HD weekend and jar name. This is 49 MB. Now, if you're thinking that I have just written a few lines of code, I've just written a 5 lines where I'm accessing my variable called a, then how come this jar size is 49 MB? This jar size is 49 MB due to this many dependencies. Okay, if I'm not adding this dependency, hardly it would be somewhere in bytes, 10 bytes, 20 bytes. So once the jar is created, I was looking for this jar. Whatever I have done so far, from IntelliJ creation, project starting, building SBT package, class, compiling, creating bytecode, this is all I'm doing in standalone machine. This is my local machine. And now I'll copy this to server. Which server? Hadoop server. Yesterday we have created a multi-node server. So in master I will copy, or in slave I'll copy. I'll copy this to master. Okay, using FTP software. So once this is copied in master, then I will run below command to submit my jar file. How to submit the jar file? in Hadoop jar from client or edge node. So below is my command. When we actually create, this is the command to submit a jar file. Hadoop jar file name, package name, class name, then input. And we know that this input must be present in HDFS. That's the first requirement. And second, output. This will be created at runtime. So this input we have copied yesterday, like we created some of the file and used Hadoop HDFS DFS minus put to copy the file. I'm talking about this input only. Okay. So let's again go back here in this 1 GB data I have already copied, and this command Hadoop jar file name, packages.class, input output. This command I'm running from my client machine. For now, you can understand this is my master machine. Okay. Now this will go first to whom? To name node or to resource manager. So name node is a master for storage, and similarly, your resource manager is master for any kind of processing. So if you want to process anything, it goes to resource manager. Then this is my number of data node. Let's say we have total 4 data node. I'm trying to replicate the yesterday scenario of multi-node cluster. So I have total data node 1 and node manager 1, data node 2, node manager 2, data node 3, node manager 3, data node 4, and node manager 4. So how this 1 GB data is distributed among your slave machine? Okay, I have total how many blocks first we'll have. So if 1 GB is there, it will give me total block 8, 1 GB divided by 128 MB. And if I replicate this 3 times using replication factor, so 8 into 3, how many blocks you will get in your cluster? Total block will be 24. How this is stored across your data node? So I have A, the same A is replicated in this machine, and let's say in this machine. How this is happening, guys? Do you remember the concept of rack? This is in rack 1, this is in rack 2, this is in rack 2, this is in rack 1. Okay. Then block B. So let's say block B is stored in this machine first. Again, this will be replicated. So block B, block B. Block C. Block C is available in my, this is getting stored in this machine. Rack 1, this becomes off rack. This is remote rack. This is also remote rack. Similarly, block D, now I'm keep writing this. Block D, satisfy the block D also. So it will go to rack 2, again rack 2. Block E goes somewhere here. Block E, block E. Then total we have copied 5 blocks. E, F goes here. F goes here, and another F goes here. Then G, G will go here, then here, and this machine, G. How many blocks so far? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, plus 4, 6 plus 4, 16 plus 5, 21. 3 blocks are pending, right? Last H. So H I'll copy, save here. Then this will be replicated again, H and H. This is how my data is distributed among my cluster. So data storage is done. Now all this node manager, all this machine, their physical machine, right? All this machine are having 4 core in total. So here I have total 4 cores available, 4 CPU. If you're using virtual machine, cloud computing, this is a vCPU, virtual core CPU. So 4, 4, 4 in total. What is my total core in, what is my total CPU in my cluster? This total CPU is 4, 4 into 4, 16, which means I can process in parallel 16 tasks at a time. I can process 16 tasks at a time, right? But I have to process just 8 blocks. I just need to process 8 blocks, not a 16. Now resource manager will submit job, okay, before job submission. Resource manager knows where data node, node manager is there, but resource manager does not know anything about data node. Resource manager is a master. We know this part, right? HDFS and MR. How many services comes under this? Name node, secondary name node, data node. This is master, master, slave. In MR, we have resource manager and node manager. So this is master and this is slave. So resource manager knows information about node manager, but resource manager does not know anything about data node, right? So resource manager will first seek information from whom? Who is keeping the metadata? Metadata is stored in data node. So, sorry, metadata is stored in name node. Data gets stored in data node. So this is name node. Resource manager is looking to get all the data information from name node. Name node will say, okay, let me see. And name node will provide all that information to resource manager, where this data has stored. Because data locality option is available with this guy. Data locality option is available with name node. The moment resource manager knows this is the data and this is how many blocks we have stored in respective data nodes from DN1 to DN4, then they will start submitting the job. This is a job submission. This process is a job submission. Multiple cases will come here. Okay, we'll see cases one by one. The moment I submit a job, my this R1 is processing A and B. So I'll change the color. A block and B block is getting processed in, let's say, R1. Then C block and D block is processing in node manager 2. E block and E block and let's say G block is processing in node manager 3. F block and H block is getting processed in node manager 4. Okay, so we'll write it here. Node manager 1 is processing A and B block. Node manager 2 is processing C and D block. Node manager 3 E and G, and node manager 4 processing F and H block. This is my total 8 block and total core was 16, right? So I can process 16, but I'm only processing currently 8 blocks because my data size was 1 GB. Now The moment they start completing the task processing, they start acknowledging resource manager. Node manager will acknowledge back to resource manager that I have completed this process. So you can again submit any task if you have in your queue. So this communication is continuously happening with all the node manager with resource manager. Similar way how your data node communicate to name node, all these data node are communicating using heartbeat mechanism. Similar way, this node manager is also communicating to your resource manager and giving the right progress status of the cluster. Okay, let's say, so case number one here. Suppose I have total 16 core, that's true, but my 10 core is already busy with some of the task. I'm building my cases here now. So case number one says only 6 CPU are free in cluster. 6 CPU is free in the cluster. What will happen in this scenario? If just 6 CPU is free, okay, across the cluster, but you have 8 tasks to process. So 6 tasks will be submitted because this is what I said. Block is equal to input split, and input split is equal to map task. If you have total 8 blocks, you have 8 input split, and if you have 8 input split, you have 8 map task, which needs 8 CPU to process. 8 CPU to process. So 6 task is submitted in 6 CPU and other 2 are waiting. If 6 task submitted in 6 core or CPU, then other two tasks are in queue. Whatever scheduler you have set, there are multiple scheduler which I'll come in a while. So these 2 tasks are waiting and there is a queue time defined. Okay, this queue works if you know the concept of data structure. We have queue and stack. Queue and stack. Queue is a FIFO, first in, first out, right? Just like if I give a metaphor of it, you guys are standing in say ATM, temples. This is in a FIFO order, or to purchase anything, and this stake is a LIFO. So you have a box and you put 10 coins that works based on the LIFO order. Now in this queue, I have given a time as 10 minutes. This is all configurable, and admin is configuring based on your cluster information. So you need to tell to admin that I need queue time 10 minute, 20 minute, 30 minute. Based on that, they will change this configuration. You cannot change it by yourself, but you should know the concept of this queue. This queue I have given as 10 minute. Let's say none of the core is free before 10 minute. I repeat, my 6 CPU was pending, 10 CPU is already busy. 10 CPU is already busy processing few tasks. So now my out of 16 core, nothing is free. All is occupied. If all is occupied and they are not free before 10 minutes, then what will happen? Your entire job will fail. If your two pending tasks wait for 10 minutes and they did not get any free CPU available, then your entire job will fail. That's why you have to balance your CPU and your cluster, and based on that, you need to submit. Now, what is the rescue point here? How can I handle this particular situation? Any idea you guys think? So my situation is same. My 10 CPU is already busy, and 6 CPU is only free. and I want to submit this 8 task. So I can do one thing. I can maybe increase the queue time from 10 minute to 30 minute or maybe 60 minute. Second option, can I customize my block size? So instead of 128 MB, which is creating 8 block, can I do this thing? Customize, customize block size. This is the solution of your problem. This is the particular solution of this case. Customize block size from 128 MB, 128 MB to let me keep 256 MB. So always we take a multiple of 64, guys. Okay, because your total data volume of any 1 GB, 1 TB, 1 exabyte, 1 petabyte is always multiple of 64. So customize block size from 128 MB to 256 MB. And what was the command to do this? Yesterday we have submitted one of the command to customize our block size. If you're remembering, what was the command? It was hdfs dfs hyphen capital D dfs dot block dot size is equal to, we need to convert this 256 MB into binary, right? That's what we did. 256 MB to binary, and then hyphen put source and destination. The moment I run this command, my total number of block will change from 8 to 4. My total number of block will be now, block is equal to input split. This is same, and input split is equal to map task. You have 6 core free. You changed your block size from 128 by default size to 256. And if I divide 1024 MB by 256 MB, okay, you can do the math from your end. This will give me total 4 blocks. So 4 block, which means 4 input split, and 4 input split, which means 4 map task. And 4 map task means this will need just 4 CPU to process. Though this will take a little extra time because one CPU is processing, if one CPU is processing 128 MB and one CPU is processing 256 MB, okay, answer is in front of you. Which one take less time? So obviously this one take less time compared to this, but according to my particular case, I do not have I do not have multiple core available where I can submit my task. That's the reason I'm customizing the block size. This is why I said this is one frequently asked question. So any data engineer will expect this answer from you. If you're saying that I do not have enough core available, then how can you handle it? First option, you can increase the queue time, but still if you're unable to understand that why your job is not getting submitted, and how do you reach to this conclusion that you need to customize the block size? You'll have to read your log file. You have to go to resource manager, which is 8088, and this resource manager will tell you how many tasks are getting submitted, which I can say using my node manager. And what is the port number of node manager? This is 19888. In single node cluster, I have shown you all this, how we can check the resource manager web address and how can we check the node manager web address. Using this node manager, I know that out of my 8 expected tasks, just T1, T2, T3, T4, T5, and T6 are submitted. T7, task number 7, and task number 8 is still waiting. They are in pending state. Okay, so hopefully this is clear. How can you handle the case number 1? Now, case number 2. Suppose case number 2. So there's a question. Can we change the block size of file which is already in HDFS? No, Hatem. If you have already copied the data in HDFS, you can't change the block size. You'll have to again copy the file. Okay, delete the previous file and recopy, changing the block size. You can change the replication factor of existing block, but size of the block cannot be changed, cannot be customized. Case number 2. Okay, suppose this block A is done. 30% this block A has processed. So this is my task 1. In my task 1, T1 is completed. T1 is completed 30%, and due to some network error, due to some network error, this gets failed. So when this gets failed, what will happen? The moment this gets failed, they're in continuous talk with the resource manager, which we are saying as a master, right? And this is a slave or worker node. Then immediately it will send one notification to resource manager that whatever task I was processing, this is now failed. It's no more working now. So resource manager knows that I had submitted earlier in number of tasks. Out of A, block A is failed. So now this will identify some other node manager where it can submit this block A. But question is not that. Question is, will it continue from 31% stage, or it will again start from 0%? So if it is failed and acknowledged to resource manager, when a resource manager identifies the same A is replicated in this machine and this machine also, so it can trigger, this resource manager can trigger the task in node manager 2 or node manager 4. I have both the option. First I will see which node manager is in nearest location. Then second I will check, do I have core available in both the node? This is all done by resource manager internally. Okay, resource manager is checking node manager 2 is having A, that's okay. This is near. I'm assuming this is near, and this has free core available to process this A. Then it will say, okay, now I will submit this block A in node manager 2. The moment it submit, again, there is one acknowledgement going from node manager 2 to resource manager saying that I have submitted and started processing this, but from 0%. Not from, it is not continuing from 31%. T1 started processing in node manager 2, but it starts from 0%. This is a problem in MapReduce, guys. This is actually a problem in MapReduce, because let's say some of the tasks you completed 99%, and due to some error, actually we have seen in the real production time, in between 90 to 100% also our many of the task is failed. So what resource manager does, it will submit it, but it will start from 0%. That's again problem and limitation, I can say, in MapReduce. But in Spark, if you're asking me, if it in Spark, what will happen? Okay, so just giving you one internal view or insights of Spark, that they can process from 31%. If any error I'm facing while processing the task, so Spark will not uh, submit the job and start from 0%. They'll start from 31%. They'll continue from where it has stopped. This is my case number 2. What if this entire data node is failed and node manager is failed? My case number 3 is, if this entire machine is down, right? So if this entire machine is down, which means whatever task I was processing in this, it's all failed. So the moment it failed again there is acknowledgement to resource manager that this machine is no more working. So resource manager will check how many tasks were processing in node manager 1. Node manager 1 is processing A and B. Okay, node manager is processing A and B. So it will acknowledge back to resource manager, and again this will be submitted to other node manager. This A and B will be submitted to other node manager if you're having failure on the node side. What if, so you have A and B available in this machine. Okay, what if this machine does not have any core available and this machine is also not having any core available? Then obviously it cannot start in this machine. Then maybe this machine can come, pick up the data, fetch it here, process it, and again write that information to this machine. But communicating from this machine to this machine and fetching, pulling this data, again going there, processing it, and again coming here and writing it will take time, because just looking at this communication, you can see I'm first communicating to pull the data, then I'm communicating second time to process it in this machine, and third time again I'm communicating to write back this information. So my always first preference, if this node manager and this data node is having that particular block, I should process the same block. If I do not have any core available and block B or block C is available in other machine, I'll pull it from there and process it. Case number 4. So failure of your task or failure of your node, both are doing same thing, right? If you're feeling A, what is happening? This A is processed in other machine. If this entire machine is failed, then whatever task you're processing in this machine, this will be submitted again from 0% to other node manager and start from 0%. Case number 3 says, okay, so I submitted a job and my job name is having some timestamp value 3415702. I'm just assuming one number 0702. So when I run this command, Hadoop jar, one second, where is the command? Yeah. So when I submit this command, Hadoop jar file name, package.class, input output, immediately it will start one job. And job will have some unique name based on the timestamp. Okay. Similar to this job, it will have one application name also. Application underscore 34157020702, and start processing your map and reduce. It will say map 0% and reduce 0%. This will start like this. Okay. In console, you can see it. Any job, when you submit using your client, they create a 2 log file. One log file is system log file, and second log file is user log file. So system log file is giving you information related to system, that how many core, how many space is free, and user log file is talking about the code which you have written using this IntelliJ. Where is my IntelliJ? So it is talking about this particular code, whatever you have written. So two things will be created. Let me tell you again: system log file and user log file. Whenever you submit a job, whenever you submit a job. Now, system log file is talking about all available resources, CPU, if you're using some part of cache, then RAM, then your hard disk, your environment, basically, your system environment, cluster environment. User log file is talking about the code which you have written in Scala or Java, and then data, which data you are processing, and task. This two log file will be there. My task 1, T1, T2, T3, T4. Total how many tasks I have? 8 tasks. T5, T6, T7, and T8. Right? This is my total 8 tasks. My T1 is completed, let's say 95%. My T2 is completed 100%. My T3 is somewhere in 30%. And the rest all is 100% done, all the task. How can I check this progress state? Using port number 19888. This is a port number for Node Manager, and Node Manager will give you all the status of this. What is the task? And even you can check this T1 is processing in which Node Manager. This T2 is processing in which Node Manager. So you can do micromanagement. 100%. This is also 100%. This is also 100%. So my most of the task is 100% done, but T1 and T3, due to some issues, error, uh, core availability, they're stuck at some point, right? Let's say this is stuck at 95%, and I am observing this job running since last 2 days. So this is a common behavior, guys, in MapReduce. When you process large amount of data, especially in petabyte and exabyte, today you submitted a job, let's say, and day after tomorrow you're checking, this job is still running. This is not yet completed. Okay, so what is the total aggregation percentage of job which I have completed here? So my job is total completed, job progress state. What is the number here? Simple math. 100 4 times 5 6, so 600, 95 and 30. 6 6 5 15 25. 625 divided by 8. This will give us somewhere, let me use the calculator. This is giving me 78.12%. So my job is completed. My job is completed 78.12%. The moment this is 100% done, this will acknowledge to resource manager that yes, we have completed the entire job. Then resource manager knows, okay, so now I have got a bandwidth and free core, so I can resubmit some other job, some new jobs. Okay, this is how the whole communication will happen. And I have given you an example of IT infrastructure, how project manager, client, and their resources communicate. The same way this whole communication is happening. You can understand this as a project manager, and this as a developer. So this guy is continuously giving a task, writing in a Jira, working with agile methodology, and telling that yes, I need 2 days, 3 days to complete it. Once the job is done, they acknowledge back to resource manager. Resource manager is knowing now how many tasks is done, how many is pending, and based on that, it is managing the bandwidth of this machine. So if this is done 78.12%, and from last 2 days, I cannot see any progress in this 95%. This is stuck. This looks like a stuck. This is though processing. After 2 days, I see this is also 100% done. Let's say this job is also from 30%. This is also 100% done. But this is not progressing any more ahead. If I kill this task, if you're thinking, then why are we waiting? Why don't we kill this? If you kill this task, guys, your entire job will fail, because this job is ultimately dependent on all the tasks. Once all the task is done, then only I can say my 100% job is done. If I kill this, then again I need to resubmit this job. And resubmitting means again this will take 100% time, and again I'll waste 2 days. So there's an intelligence built by resource manager to handle such scenario. And that concept is known as speculative execution. Speculative execution. Some of you, I think, already have completed the MR in the classroom, but I don't know whether you have completed this all the course cases or not. But these cases are very important, guys, to know. And we will be using this all analogy in a Spark and Hive wherever we need to use this MR as our execution engine. So speculative execution is one kind of mechanism. This is one type of mechanism, and this is completely taken care by resource manager. What resource manager does, so resource manager will say, okay, I'll give me the time that if this is not working from last 40 hours, this is not processing any percent ahead, it is stuck at 95%. So if I put a time in my property file of resource manager and say that if this is not progressing after 40 years also, so launch me one speculative task. Let me write a note here. So I fix the time as 40 years. So we have given a time of 40 years in configuration. And if you remember what was my configuration file name for resource manager, that was a yarn-site.xml. So in yarn-site.xml, I can write it, or I can write that in the scheduler. So we have given a time of 40 years in configuration. If any task is stuck and not progressing more than X%. So whatever the percent is, not progressing more than X% and is stuck for more for 40 years. The moment it reaches the 40 years, that ticks the time, immediately it will launch one speculative task after 40 years. It will launch one ST1. So this ST1 is a speculative task, and it will start from 0%. Whichever gets completed first, suppose this T1 starts now and completes 100%, this ST1 will be automatically killed. If ST1 starts from 0% and after some time this reaches to 100%, then it will kill this T1. Whichever completes first, they kill another one. This is the whole concept is known as a speculative execution, and the task which resource manager is launching, this is known as a speculative task. So this time I can configure 40 years. I'm just taking one example. Don't think that this is just a 40 years. I can give 10 hours, 5 hours, 2 hours, 1 hour, 10 minutes also. So this is all configurable. And this configurations I'm giving guys in my scheduler. So Hadoop works with three different schedulers. 4 is introduced in Hadoop 2.x, which I'll come while practicing with Spark. So basic scheduler for Hadoop, and if you want to read this all about it, uh, all you have a Hadoop definitive guidebook, right? So Hadoop definitive guidebook, read the chapter number 4, which has topic name yarn. Okay, for theoretical part. So if you read the chapter number 4, what I'm talking, you'll see it there. Scheduler is having FIFO scheduler, second is pair scheduler, and third is capacity scheduler. FIFO, as the name implies, with first in, first out, right? So first in, first out means this is not good for production, obviously. Suppose I submitted a 10 job. I submitted a 10 job using FIFO, using FIFO. we submit 10 jobs in Hadoop cluster. So what will be the order? Just like in a queue, J1, J2, J3, J4, J5, and so on till 10th. So this is my jobs. How they are priorities set. This is what is a priority. That J1 will complete first. After that, J2, J3, and so on till 10. But what if my business asks me that this job is very important? They ask me on ad hoc basis that I want to complete this J5 at first now. I'm not waiting for the time that once it reaches to J5, then it will start. I want to start it immediately. Uh, let's say this is uh, your project courage number 5. Okay, so we define the project based on their value and what business value they're bringing. Now, business is saying that J5 needs to complete first. FIFO cannot help me. FIFO is failed in this case because if I want to change the priority, I need to kill this entire queue. I need to cancel the queue and resubmit again. And then there I will give priority of J5. What if my business then asks me now this time I need J to be processed first? Then again I need to kill this. So option is given, but not a good option, especially for multi-node cluster. This is good when you're practicing in single node machine. It's good because in single node machine you have only one node and you have only few core, 2 CPU or 4 CPU available. In that case, this is absolutely fine. But in the case if you have multi-node cluster and thinking that I will create a FIFO scheduler, this is not the right option. Second point is fair scheduler. Fair scheduler, from the name itself, it says fair scheduler. And where to set this all the value? There is a property, guys. In Hadoop, there's a property. Let me show you that also. So I have installed local in my local also Hadoop. This is the same cluster, okay, which I'm showing you. But my system is 1 second. CD. Yeah, my system is Unix based. And, Java minus person. This is the configuration location of Hadoop, LSLRT. You'll find it here. Capacity scheduler.xml. Then two more scheduler I think is inside SBin for this. FIFO and fair is uh, inside the SBin, this directory. So fair scheduler, what we're doing inside fair scheduler. Fair scheduler again, this is good option, but not completely supporting production environment. Why? So let's say I have this time 5 jobs available total. My job number 1, job 2, job 3, job 4, and job 5. What I'm calling a job. So when I submit Hadoop jar and jar file, that input file which I'm processing is nothing but my one data. And to process that data, I'm creating one job. That's what is a job. And based on the data size, I'm having number of tasks. So suppose I have 100 MB data, I'll have one task. If I have 200 MB data, I'll have two tasks likewise. So do you think that all the job is having same size? Obviously, all the job is having different size. Maybe this is processing 4 tasks, T1 to T4, T1 to T4. This is having just T1 and T2. This is having task T1, T2, and T8, just like we have seen our previous scenario. and T4 is having T1 and T20, 20 tasks, and this is having T1, T2, T5. What fair does, fair scheduler will give equal space, equal CPU RAM available from the cluster to all this job. So let's say my total memory to process this task and job is 100%. My total memory is 100%. I'm starting from scratch, submitting this job first time. So fair scheduler will submit 20%, 20%, 20% to each job. Don't you think this is a problem? Because I have T1 to T2, T20. This is very large. This is very large job. The job size is very big here. Okay, and how many data I'm processing? If you think that way. So what is my total task? 20. Can I calculate 20 into 128 MB if I'm using my by default block size? Because I've written multiple times that number of block is equal to number of input split, and number of input split is equal to number of match task. So if I have 4 tasks, which means I'm processing 4 block, I can multiply this, right? So that's what I'm doing here. 20 tasks into 128 MB. This is giving me 2560 MB, roughly 2.2 GB. This is processing 2.2 GB of data. This can be any data. This is having 128 into 4. So 128 into 4 will give me 512 MB. Then T1, T2, this is 256 MB. This is my data size, okay? This is my data size which I'm processing using using my MapReduce program. This is T1 to T8, this is exactly 1 GB. T1 to T5, this is 512, and another 128 will give me 640. Looking at this data size, if you're still saying that I will give 20% to all, so how your job will process and which one will complete first? So completion is, ranking is as follows. This will complete it first. This will complete it second because size is very less. This will complete it third, then fourth, then fifth. This will take a lot of time to process because size of data is very high. So ideally I'm thinking that why I am giving this memory 20%, 20% to all the job, why I'm not able to give more memory to this? Maybe if I give 40% memory to this, all the jobs should be completed in same time, equal time. So fair scheduler is also failing to provide more and less. They're saying, okay, so 5 job is there, I'll provide 100% divided by 5. If 10 job is there, I'll say 100% divided by 10. If 100 jobs is there, it will say 100% divided by 100. They're not checking the internal task. They're not checking the size of their data. So all these cases can be handled using my third scheduler, which is capacity scheduler. All this can be handled using capacity scheduler. And in capacity scheduler, I can actually fix my quota. I can say the quota wise, like regular jobs, whatever jobs I'm submitting on daily basis, it will occupy 75%. This I will set in my property file. This I will set in my property file. So we write a property, then we write a name, then we write a value. This is one XML, right? Single node cluster, we did this all manually. Then this is again closing the property. I'll set this value of 75% here in this property file. And for ad hoc or on demand jobs, for ad hoc or on demand job, which business can ask me to submit anytime, I'll keep my 25% memory free. So whenever they're asking me to submit any ad hoc jobs, I'll submit there using this 25% memory. This is what can be provided by your capacity scheduler. So three schedulers. Best one and the production one is capacity scheduler. In fourth scheduler, there we have yarn scheduler also. We'll see that in Spark. We use in Spark that yarn scheduler much using scanning methods. So far, guys, in nutshell, what we have seen, how I'm building my job, this jar file using IntelliJ. There are two different methods. One is a manual method to create a jar. One is a built-in tool, SBT and Maven. So since we're doing a Scala thing, our main idea or intention to write a code using Scala. Then create a project, write classes, build some logic, compile it, write some test cases if you wish, because that's what we do again in real-time cluster. And after my test cases, everything is done, I'll create a jar and copy to server using some FTP software, this FTP software. Once the software part is done, I've copied it, then I'll submit from this client, which can be an edge node or master. When I submit it from here using Hadoop jar command, it first goes to resource manager. Resource manager is knowing all the location of node manager because this is master, this is slave, but it does not know anything about data node. And hence it is checking from name node that can I get data node information. Name node is having all this metadata available. Name node will list which data node is in the near location, and it is having which node manager within the system. Then provide that information to resource manager. Resource manager will start submitting. Three failure cases. If A will fail, what will happen? Resource manager will submit to other node manager where the A same block is available. First priority. If A is not available, then other machine will come, pull up the data, take it there, process it, and write back to the system. Third, if this entire machine is down, what will happen? Fourth, if CPU is not available, enough CPU is not available in our cluster, what will happen? Now, when you lose this data node and node manager, anything you're losing, that process is known as a commissioning and decommissioning. Okay, so whenever your slave machine goes down, if your slave, and the slave is data node and node manager, slave goes down, we need to commission and decommission. We need to commission and decommission. So always this commissioning and decommissioning is done by administrator for slave machine. This is not applicable for master machine. Okay, so if I'm losing one node manager here, I will decommission this. I will decommission this and add one more data node and node manager using commissioning. So decommissioning means removing and commissioning means adding. Only in the case of failure, or in the case of when data size is getting high, when your volume is increasing, right? Suppose you just have currently 4 data node available, and all this data node is having 1 TB as a hard disk. So total, including this DN1, DN2, DN3, and DN4. What is their total storage if I include all of this? Keeping in mind 1 GB, 1 GB to all, I have 4 GB available, 4 TB available. What if my business want me to write 2 GB extra file in this cluster? Okay, understand the scenario. What if my business says that I want to write 2 GB file extra because my business value, my data size is coming more now? Then I'll say, okay, no problem. I will increase number of data node. And instead of having 4 data node, I'll say, can I commission 2 data node more, which is my DN5, 2 data node, DN5 and DN6, which will have 2 TB extra hard disk and 4 TB plus 2 TB. Now I can balance my cluster. So this is keep happening. Commissioning and decommissioning is every month or every year happening. This is not that once you define the cluster is running forever. Every time, based on the failure, based on the requirement, you need to do this commissioning and decommissioning. You need to do as in this part is taken care by administrator, but yes, who is writing incident whenever you need such information, right? Currently, say you have created this cluster, you can manage it, but in production cluster or in your development environment or a site environment, if you want to increase this, then what is standard flow says, whenever you want to do this, you'll have to create a change task. Whenever you want to do this, case number 5, I'll consider this as, if you want to make any changes, if you want to make any changes in cluster, you can't do that by yourself, right? So to do above task, we will have to write one incident, and incident, inside incident I will write my technical task. I'll write that my business data is growing and my business is asking me to increase the size of data node. I'll submit this technical task along with the incident number to whom? To admin team, admin Q team. So admin Q team, whoever is available at that particular time, they'll pick up this, they'll assign to the person who is working on this task, and then I can directly communicate to this person that he can ask me why you need what information. If this is not known, if this is known, then directly it will implement it and give me information that this incident has been closed. You can check it and tell me that what you was looking is done, or you want some other amendment in the cluster. That's one. Second, if you want to create a, if you need some other work, not existing work, you want to uh, create a new create a new requirement, right? So this new requirement cannot be managed with INC incident. This new requirement, you'll have to write a CR, which is a change request. So inside change request, again, you will write XYZ information along with the technical task that I want to do this. And again, this you will assign to administrator. Remember, any environment related query. Okay, if you're working with Hadoop cluster, your Hadoop is not working, your services are getting down. So every time you'll have to write a CR or incident based on the new task or existing task and assign to admin. This is what is a process. So in book you can read what is Hadoop, what is MapReduce, but process part is important also, especially to crack the interviews. Because in question they'll not ask you what is MapReduce, they'll not ask you what is multi-node cluster. They'll ask you when you submit a job, what will happen? If your one job is getting filled, what will happen? What is the process? What you do when you log in your office at 9 a.m. to 6 p.m.? What you do in this time every day? Do you write everyday job? Because job creation is just a one-time activity. Once your project is live, what you're doing, the project code writing is done, then you are maintaining this. Maybe you are jumping into another project coming by your company, taken by your client, or if there is no, then you're supporting this. You're checking your cluster, your environment, you're writing CR incident. This is everyday task. This too is everyday task. We'll be doing this every day, managing the cluster. So resource manager submits job to node manager and tasks for data models, details from name node, and then submit the job to name node with details of the node. Name node. Let me read the Hatham question again. Job to node manager and ask for data node details from name node, then submit the job to name node with the details of data node. It's not submitting the job to name node. Okay. What is happening? So let me go back again here. I'm repeating again, guys, because some of you are having one doubt here. So The entire process is happening this way. Client is submitting. Okay. Now, client once submit, it goes to resource manager. I'll actually show you when I run this job. Okay, currently I'm just giving you the graphical views that how this will happen, because directly if I start doing practicals, then you'll amaze that how this whole communication is happening. When you submit a job, when you especially run this command, okay, uh, let me write it here. If you run a job, so when you submit a job using this command to submit a job, I'll rewrite it again because this is very important to understand. Hadoop jar, Hadoop jar. I'm running this from client, right? So assume this as a master according to our previous scenario. Hadoop jar, and I will give this jar name. I'll give I'll give this jar name. Can I write this jar name? Actually, I should write this jar name to make it more clear. So what is the jar name? HD weekend 11:45 dot jar. Let me use this name. So I'll go here and type HD underscore weekend underscore 11:45 am dot jar. This is my jar name, which I've copied. Then my class name. What is my class name in my IntelliJ? Class name or object name? Okay, I'll give this name MR. This is my object name. This I'll give here MR. So you can give both. Okay, class will also work, object will also work. I'm giving object name MR, and then input. What is this input? This input is this file. This input is this file which you have copied using the command. What is the command to copy the file? Command to copy file from LFS to HDFS. This command is HDFS, DFS. We have run many times, right? Multi-node cluster. I think the whole communication of yesterday was mainly focused in this area. HDFS, DFS minus put, and source and destination. This is my input file. So let's say I'm copying a file name uh, weblog. So I have one weblog file stored in my local file system, and I copy this to HDFS big data folder. So this will go inside big data folder. This is my input. Here I'll say big data slash web log. This is my input and must be present in HDFS, because if this is not there, you get input path does not exist. And output can be anything. Output I'll give big data and process wave. This folder should not be present by default, because if this is present already, you'll get exception. Already exist. Your directory is already exist. So remember this 2 point first, and start knowing the error and start logging, in fact. So when you practice, I'll suggest start writing this error and exception in your file, because when you write this error and exception in questions can ask in real-time interviews that in so definitely you guys will aid a project. So when you aid a project, they'll ask you in this project how many problem you face real time when you create a job in MR, when you create a job in Spark, when you did scooping, when you work with Hive. So all this error and exception, if you keep logging, you know that this error is coming at what situation. This exception, how can I handle it? This is my output directory. Once I submit this, and I'm submitting this from here, I think now it's clear. And this is going to resource manager. Resource manager knows that where is that node manager location, because when I submit this, immediately it will go to the port number called 8088. Immediately this will go to port number. After submission, this it will create a job, and give me the port number of 8088. If you remember this 8088 port number, this is a port number of resource manager. I'll show you this in practical, don't worry. And once this goes to 8088, it knows where is a node manager because they communicate using the port number 19888 and 8088. Communication between this port is happening interchangeably every time from this to this. But resource manager does not know anything about this data node. And to get this data node information, it is seeking information from name node. That can I know where the data is located? Because if this resource manager knows this is the node manager and this is the data node, it can manage it effectively. It can handle the cluster well. Okay, that's the reason it needs to know the location of data node. Once this is done, then resource manager submit and the whole communication then happens with the help of application master, job history server. Those things are yet to come. Currently, we are just focused on resource manager and a node manager, how this communication will happen, and how can we handle the errors in actual scenario. Now, in MR, we have two options to write our job. In MR, we have two options to write our job. So Hadoop is providing me, let's quickly compare Hadoop 1.x and Hadoop 2.x. Though this is deprecated, right? Nobody uses today first generation. Everybody has moved to second generation. We got this 2.x in 2012. So let me write the year. This is stable in 2008. We got a stability of second generation in 2012. Hadoop 1.x is having just one name node. That is the reason here your high availability option is not there. Because if this name node goes down, your entire cluster of Hadoop is down. You can't do anything. You'll have to wait until and unless this name node is not again up or active. But here, since you have multiple name node, high availability option is not available here. It's not available here. And high availability option is available here. Why? Because of multiple name node. Okay, maybe in coming Saturday, I will start with this HA first. I'll create architecture of HA and we'll see how the whole communication will start. Third, they have one job tracker. And what is the by default block size in first Hadoop 1.x? This is 64 MB by default block size. And by default block size is here 128 MB, which you can customize. You can customize here also, you can customize here also, based on the CPU availability and your processing high speed. Then third option, there we call slots. This is a container where my jobs are getting submitted. Difference between slots and container we'll see. Then here we have job tracker. Instead of job tracker, here I have resource manager. Resource manager. Here we have task tracker. Here we have node manager. So this two thing is replaced in 2.x by this two name. If you have practiced earlier in 1.x and still thinking where the job tracker has gone now in 2.x, so it has not gone anywhere. It has just changed the name from job tracker to resource manager and task tracker to node manager. But in 1.x, we go in detail and see. So job tracker is doing three tasks. In Hadoop 1.x, job tracker is doing submission of job, which is a job submission. Second, they track your status of job. They track the status. Status when I say whether they are completed, pending, done, waiting, killed, hold, okay, queue time, waiting time, all these things are tracked by job tracker. And port number for this job tracker, if I remember, this was 50030 in 1.x, right? And another one, They are managing the job history also. They're managing the job history. So all three different tasks is done by just one daemon, one service. What if I change it a bit? In 2.x, this all these three things are taken care by three services. So resource manager is only responsible. Resource manager is only responsible for job submission. Uh, who is tracking the status of job here? In 2.x, this is application master. Application master is tracking job status. Then third, after application master, third one is a job history server. So if you remember yesterday when I run JPS command in my master machine, so you see this application master and job history also, right? Which is not present in Hadoop 1.x. This is managing job history server. This is known as a timeline server actually. Timeline server. This manages your job history. Now you guys tell me, if one service is taking care of three things and three services are taking care of three different things, which one will give me better performance and optimization? Obviously the 2.x. And here in 2.x, this whole thing is known as a yarn, which was big time missing in Hadoop 1.x. Because in Hadoop 1.x, I have this scenario only. In 1.x, I had HDFS, where I used to store the data. And second, I had MR. Using this, I am writing the job and reading the data from here, processing it, and again writing back to here. No computation layer, nothing. Everything is done by MR and HDFS. So low grade in the performance. Okay, that is the reason before 2012 Hadoop was not popular. It was there in the market, but people used to say that this may not go in future and handle the big data analysis. But in 2.x, they come with another layer called computation layer. So in place of this HDFS and MR, this two is there, and we have got Spark also here, right? We've got Spark also as a application layer. In between these two, we have got another layer, and that layer is known as yarn. So in our next class, I'll start with this yarn, see some of the components, how HA works, and then we'll start knowing some of the fact of MapReduce, like compression technique, input format. MR is not yet done, guys. MR is a big thing, and if you're reading a book and trying to understand the whole concept from chapter number 5th to chapter number 9th in Hadoop Definitive Guidebook, you can find all the topics related to compression and whatever I have discussed today. MR Spark is this is application layer. This is my computation layer, which is computing my CPU and RAM. And HDFS is my storage layer. Storage layer. So what this computation layer is doing, it is computing CPU and RAM. And whenever I submit any job, they see that that job needs how many CPU and how many RAM to cache in between and submit in the CPU. We have little RAM available here. That concept is a distributed cache. Okay. So CPU and RAM, this computation was missing in 1.x. We had just application layer and storage layer. Spark was also not very stable with first generation. But in 2.x, we have got another layer, which is my third layer, which is providing me for any job, they're computing me CPU and RAM internally. MR is not doing that. So this is why my performance is very high in 2.x, just to following this components and concept. So HA and other components of Hadoop we'll see.